Hello and welcome to a new video here on my channel here at commaik. In this video, I'll show you how I install my old Viva diesel heater, which I have repaired and cleaned in my basement and operate it completely self-sufficiently. For this, I will install a new canister with a suitable tank extractor. I will be using a transformer. I have plenty of accessories for the exhaust and the mounting. And I have this special part. And if you want to know how it all works, how I do everything, then stay tuned. We're about to get started. In one of my last videos, I showed you how I disassembled and cleaned my old Viva 8 kW diesel heater. Now it's running perfectly again. The heater is left over. I'm going to install it here in my workshop. Up until now, I've been using the Croak TB2 in my workshop. That's this awesome unit in a suitcase. I can take it anywhere and use it on the go. And I want to do that much more often in the future. That's why, unfortunately, I can't install it permanently in my workshop. But this diesel heater I can install permanently. What's my goal? Quite simple. My workshop, which you see behind me, has a cold basement underneath. There's another basement below the basement, and that's where I'm going to install the heater. I'll run the exhaust through the ceiling between floors, along the wall behind. I'll build a mounting bracket. I'll install the ventilation holes so that they come out of the back wall here at the rear. I'll modify the remote control so that I can operate the heater from up here. Let's see if I can manage that. My Viva diesel parking heater was originally integrated into a portable carrying case. The portable heating box also had the diesel tank and the pump built in. All I needed was an additional power connection. I disassembled this box and integrated it into my large heating box in such a way that I can take this large heating box, including the tank, power supply and accessories, with me. At the moment, the heating box is running outside by the animal house and makes sure that the budgies don't freeze in winter. With this Chinese heater that I want to install in the basement, I now have the problem that I somehow need to mount it on the wall, and that's where this part comes into play. This metal bracket already has the necessary holes I need pre-punched. I have holes for the exhaust, the fresh air, the diesel line, and the screw holes. The side opening is also already there. I can simply attach this directly to the underside of the heater and screw it on. What I still need is an additional exhaust pipe for the gases. I need a hose to draw in the fresh air that will be burned in the heater. Of course, I also need a connection to pump the diesel from the tank into the heater with the diesel pump. I have to install and secure the components outside of the parking heater. Well, how do I do that? Since I was unable to locate a suitable metal plate for this project, I am now going to precisely cut an 18mm thick OSB board to the exact required size and dimensions. The board will be large enough to also mount the transformer and the distribution box on it. I also need to install the connection for the remote control there so that the cables aren't dangling around individually. Now I'll show you how I'm going to install it. Afterwards, the whole construction will be mounted in the basement. Then I'll lay the ventilation pipes in such a way that I can heat this upper area. At the same time, the basement will also be heated. Down there, it's relatively cool at around 10 degrees C, both in summer and winter. It's also a bit damp, of course that's how it was intentionally built back then. With a T-piece, I genuinely want to bring a bit more warmth down there as well, ensuring a comfortable and consistent temperature. The robust bracket is securely pressed onto the specialized decoupling mat, which effectively minimizes vibrations and sound transmission. It can then be very easily and firmly fastened with the appropriate screws, providing a stable and reliable installation for long-term use. I screwed the bracket onto the heater. On the left side, the room air is drawn in. On the right side, the heated air is blown out again. The intake for the combustion air can be seen on the left side. On the right side, you can see the connection for the exhaust. The exhaust pipe needs to be routed to the left side. On this side is the opening through the house wall. So I have to somehow get the exhaust past the fresh air pipe. And I do that by bending the exhaust hose so that it fits comfortably past it. I don't connect the exhaust pipe directly, but instead install this additional construction. What you see here is a condensate drain. That's because the heater is about 3 to 4 meters underground when I've mounted it on the wall in the basement. When the heater is running, condensate naturally forms in the exhaust system. The moisture is evaporated during operation and blown out through the exhaust, but not all of it. This means that the condensate runs back down the pipe and collects at the lowest point. Eventually the pipe will start to rust and the exhaust gases will leak out. And that's why it makes sense to drain the condensate. That's what this component is for. It is installed in the exhaust line and sealed with exhaust assembly paste. Additionally, I will secure it with a pipe clamp. I can also connect the parts to the exhaust pipe. The condensate is then released through this small opening. To ensure that only the liquid comes out of the hole and not the exhaust gases, this spiral is added. This part also has this beaded conical connector. It is connected here in a watertight and airtight manner. I'll go ahead and screw it tight. Once it's secured, you have to imagine it like this. This is the lower section with the lowest point. Here, the condensate runs down again. It collects here and will first gradually fill the spiral. After that, it will drip out here. Because this spiral is completely filled with condensate, the exhaust gases cannot escape. The pressure isn't enough to blow the water out. I'm really curious to see if this investment was worth it. By the way, if you want to know where I got all the components from, take a look under the video in the description. I'll link the components there for you. That way you can easily build the heater yourself. I'm turning the heater over again. As I mentioned before, I want to lay the exhaust pipe in such a way that I can easily get past the fresh air intake. I've already carefully bent the exhaust pipe a little bit for this specific purpose, ensuring it fits perfectly and functions as intended. Now I can attach the pipe for the combustion air. It fits. This pipe is also made of metal. It can't be damaged by the heat. I'll also apply some exhaust assembly paste here and tighten the pipe further with a pipe clamp. Of course, I'll do the same at the connection to the muffler. I've screwed the board to the bracket and also attached the decoupling with the pump to the underside. The hole is large enough for the condensate drain and the air supply to pass through. The fuel in the hose can also be pumped through this hole into the heater. Before I attach my board with the heater to the basement ceiling and then install the electrical components on it, I'll first take care of the fuel supply. For this, I got myself a larger tank and now need to install the tank extractor. I also still need to build the supply line from the pump to the tank. The tank extractor is installed. A quick check shows that the pipe actually reaches all the way down to the bottom. I have mounted the heater on the wall of my basement. I'm going to take you down into the catacombs now. I'll show you how I did it. Down here in this small quaint basement, air raid shelter, vegetable cellar, coal cellar, whatever it's been used for over the years, I've mounted the heater on the wall. As you can see, the board with the brackets is screwed directly to the wall. I installed the diesel parking heater as follows. The exhaust hose runs underneath the heater, curving past the air hose. After that, I routed it up through a hole in the ceiling, along behind my OSB board and out to the exterior. Behind the OSB board, I wrapped the pipe with a special heat protection pipe insulation. This way, the OSB boards are protected from the heat of the exhaust. The air hose that brings combustion air into the heater, I first clamped into the bracket. Later, I will secure it to the board with a clamp. Then I connected my diesel canister here to the pump with the fuel hose. At the moment, I'm still using these green aquarium hoses. I'll replace them when I get the chance. The hose I actually wanted to use unfortunately drew in air. I'll have to find another one. I laid the hose in a loop. The diesel is pumped around here. The diesel flows into the filter from above. From there, it is directed down to the pump. The advantage of this system is that any air that accumulates in the hose always stays at the top. No air is drawn in. This has proven to work very well so far. The pump draws in the diesel and pumps it through the hose directly into the parking heater. The wiring still looks a bit chaotic at the moment. I want to install the remote control upstairs in my workshop. I mounted the transformer back here. The power cable goes directly into a socket. I connected the outputs of the transformer together using a Wago terminal. The 12V connection for the heater, which is this black and red wire, I also connected to the Wago terminal. The 12-volt DC now supplies power to the heater and the pump. The connection is protected by this fuse. For now, I have temporarily installed and connected the remote control. The cables for the pump and the remote control are bundled together in a wiring harness. At the moment, the remote control is just hanging from the cable. I had previously cut this cable once before. Between the wiring harness and the remote control, I had previously installed a control cable about 3 meters long. This allowed me to control the heater in the heating box from inside the animal shelter. I had designed it so that this section of the cable was outside in the mobile box. Inside, I had extended the cable up to this connector. That's where the remote control was connected. I'll do exactly the same thing here. I'll open the terminals and connect a longer control cable. I'll run the cable up there along the ceiling to my OSB wall. Then I'll route the cable up inside the hollow wall. On the other side, I can then connect the remote control to the cable and screw it to the wall. But I don't necessarily have to use the remote control. I also have the option to use the app on my mobile phone. I've already paired the app via Bluetooth. I can control the diesel parking heater entirely with the app. Let's go ahead and turn it on. You can clearly hear the fan and the heater starting up right away. The glow plug preheating process takes a little while to complete. The heater has also turned on the remote control's display. The desired target temperature is 26 degrees Celsius. However, the current room temperature is only 10 degrees Celsius, which is quite a significant difference. This warm air hose is also just a temporary solution at the moment. This hose was included with the parking heater. It's only 60 centimeters long. I'm going to build the ventilation system differently. For this, in addition to the extension cable for the remote control, I also bought an air distributor. This substantial 75mm T-piece will be carefully placed here on the wall and securely connected to the heater. Downwards from this point, I will then lay a relatively short ventilation pipe. In this efficient manner, I can also effectively heat the entire basement area. With the upper connection of the T-piece, I will heat the workshop. For this, I'll install a new heating pipe. This ventilation pipe can be extended to over 3 meters in length. I have 2 of these. With the couplings, I can also extend the pipes. I will run the ventilation pipe up here along the OSB board and then install an air outlet. The truly great and remarkable thing about this particular T-piece is its incredibly useful and precisely engineered built-in throttle valves. With these highly effective valves, I can meticulously and accurately control the exact amount of air that flows through the system, ensuring optimal performance and precise adjustments. By utilizing the throttle valves, I can precisely control the exact amount of air that should ascend into the workshop area and how much should be effectively blown into the lower sections down here. For the basement area located down here, I will only open the throttle valve ever so slightly. That way, a significant portion of the heated air will effectively go up into my spacious workshop. The area down here will still be adequately warmed. This also effectively reduces humidity levels and ultimately creates a much better and more comfortable climate. So I've been talking for quite a while now. As you can tell, the heater is now running. The ambient air is already noticeably and pleasantly warm. You can clearly observe the steadily rising temperature on the shiny aluminum heat exchanger, indicating its efficient operation. That should continue to steadily rise shortly. The heat exchanger is precisely located on the right side of the heater. This is it right here. It is heated from the inside by the powerful flame. The ambient air flows past on the outside and is warmed in the process. And this heated air is then effectively blown out through the opening, providing warmth. This sensor, which is located on the top of the aluminum body, has already measured temperatures of over 200 degrees Celsius. So the air coming out of there is very hot. The exhaust hose on the back also gets very hot. I deliberately left the exhaust hose a bit longer. The length is just right to blow out the exhaust gases along with the soot. This way, the exhaust pipe stays free from dirt, dust, and deposits. I can still use the waste heat from the exhaust gases to heat the basement. You can see it. The temperature at the sensor is 98 degrees. Now it's 100 degrees. It works. I will reinstall my CO2 smoke detector down here. This way I can be sure that all connections, especially those on the exhaust, are sealed tight. No exhaust gases must escape and enter the house. Everything has to go outside. Better safe than sorry. I've now also installed the ventilation pipe and the remote control on the parking heater. The diesel heater has now been running continuously for a few hours, and it's time to show you the results. I've installed the T-piece. Now the lower basement is being heated as well. The temperature down here is 20 degrees Celsius. Do you remember? Before it was barely 10 degrees Celsius. I extended the remote control cable with a clamp. I then routed the cable upwards behind the ventilation pipe. The cover of the distribution box is put back on and screwed shut. That way the electrical components are protected as well. The ventilation pipe runs along the wall up here, secured with pipe clamps. By the way, the aluminum pipe is noticeably warmer than the black ventilation pipe. It's hot. Up here I got a bit creative and tried to lay the ventilation pipe in wide curves without any kinks. This way the airflow isn't slowed down too much. I ran the cable for the control unit into the wall next to the pipe. Inside the OSB hollow wall it runs upward to the remote control. I'm back in my workshop. Down here you can see the air outlet. The ventilation pipe is connected from the back. I can really feel the warmth, but the airflow isn't bothersome. I've mounted the remote control here on the wall. With it, I can conveniently turn the diesel heater on, control it, and turn it off, just the way I want it. Of course, the app on my phone works up here as well. With the heater set to level 2, I was able to raise the room temperature from 10 degrees C to 17.9 degrees in just under 2 hours. I'm quite satisfied with that. On the highest setting, you can hear the fan and also the clicking of the pump. The sound is transmitted through the ventilation pipe, but on level 1 or 2 you can only hear the clicking very faintly. I can still hear the airflow from the air outlet, but that doesn't bother me because this is my workshop. It's a workspace. Well, since I'm almost finished with this project, I'm now asking myself, what should I do with my Croak TB2 diesel heater? You remember, in my last video I installed and tested this heater in my workshop. Now I don't need it anymore and can use it for other projects. I'm not sure whether I should just sell this mobile and portable heater, or should I raffle it off to my subscribers? Maybe there's a great idea for a new project. Give me your feedback below the video and leave me a comment. What should I do with the TB2? I'm looking forward to your responses, even though I can already imagine which direction your wishes will go. If you want to know what happens next with me, then subscribe to my channel. Give me a like for this video. If you also want to build a workshop heater and want to know which components I used, then take a look below the video. Everything I installed is linked for you below the video. You know the drill. I finance my channel with these affiliate links. You can click on the links and buy the products. Same price for you and a small commission for me. Thank you very much for your support. I'm looking forward to the next video. I'm even more excited to read your comments under this video. Until then, take care. Bye.